In this video, I just want to give you an introduction to LaTeX. So first off, I called it LaTeX. And if you look at the name of it, it seems to be like it's latex, but we actually do call it LaTeX. So LaTeX is a technology for creating documents, and it's used very widely in science and academia. So if you do graduate school, like you do a master's or a PhD, and you write papers and write articles like that, there's a very, very, very high likelihood you'll be using LaTeX. But it's also used quite a bit in undergrad as well, just to present different presentations and documents and so forth in your different courses. It's actually been around for decades now, and it uses the TeX typesetting system. And the pronunciation of LaTeX, that goes back to the people that created it. But Donald Knuth is a famous computer scientist, and he said it's pronounced LaTeX. So we're just going to go with it. We're going to go with LaTeX. So it's pronounced LaTeX. So LaTeX documents are actually plain text documents, and they contain a markup language that is going to define things like document structure, like the sections of the document, the title of the document, the author of the document, what graphics to include, like what images to include, definitions of tables, so how they should look and how they should be presented, and mathematical formulas. A LaTeX document gets compiled to produce a document that is made up of pages or slides. So we take that plain text document, we run LaTeX, and we produce a document in an output format that is going to be pages or slides. And we can produce PDF file formats, or we can produce this DVI format as well. We'll just use PDF in this course. So you might have noticed when I was talking about how LaTeX works, that it sounds a bit like HTML in the sense that HTML also is made up of plain text documents that contain a markup language. And the markup language defines document structure, things like paragraphs with paragraph tags, headers with header tags, links with link tags, and so forth. And the browser takes that HTML document and compiles it to generate a web page's output. So LaTeX is pretty similar to HTML in some ways. Another way that it's similar to HTML is that LaTeX also follows a design philosophy of separating content from presentation. So that's a key thing with LaTeX. When you write a LaTeX document, all you're concerned with is structure and content. But the actual laying out of the document is handled automatically by LaTeX. So HTML works similarly. In HTML, you specify the document structure with your paragraph tags and divs and spans and all those kinds of tags. And then CSS is used to define presentation. So philosophically, it's similar that way as well. So LaTeX distributions exist for Windows, Mac, and Linux operating systems. And you can find them and install them at the LaTeX project website. Some distributions support a graphical user interface to write documents. So you basically get what's called an integrated development environment, where you're given a text editor to actually edit the LaTeX document itself. And then you can actually generate the PDF, and you get a report about any errors, all in sort of one integrated interface. I've never actually used that before. I've always just sort of used the text editor and then just used the command line tool, PDF LaTeX. And I just run PDF LaTeX document.tex or whatever I've called it. And then I just generate the PDF that way, right on the command line. So I'll show you both ways just in case you're curious. We name LaTeX documents with the extension .tex by convention .tex. So in terms of the latexproject.org website, might as well check that out. So if you just go to Google and you type in LaTeX, it's the first website that comes up. And if you go to Get, this is where you can actually find the different distributions. I don't know why it pops up with an ad, but you go to Get. And if you scroll down here, you got Linux, Mac, Windows, and so forth. There's even some online services nowadays too. But for me on a Mac, I got this MacTeX distribution. I've used MacTeX on Windows and actually the other two as well. They've both been fine. I've never used a Linux distribution, but I'm sure they're fine as well. So I've already downloaded MacTeX and I've already got it ready to go. So let's just try to actually make our first LaTeX document with that now. Okay, so I'll launch the program so we can get going with it. So I'll say tex. And it comes up with this text editor within this text shop IDE. You don't have to use this, like I said, and I'll show you how to do it with a regular text editor. But this is basically just a text editor that's kind of purpose-built for LaTeX. And after you've typed up your document here, you can say typeset, and it tries to compile the document and produce a PDF. So let's just start working on the document. So LaTeX documents, like I said, they're made up of this markup language, and we can call them LaTeX commands. So they begin with a slash. So we say slash, and then you give your command, and it takes in arguments essentially. So we're going to say here, document class 12 point article. And this is basically telling LaTeX that I want to have this type of document, an article. And this is just modifying the font to say 12 point. This is like the first command you typically see in a LaTeX document. We can have some other commands. So if I say slash title and I say assignment number 1, that's going to set the title of the document to be assignment number 1. It doesn't output the title to the page, but it does set the title to be assignment number 1. And so this is essentially sort of information about the document. It's not specifying how to output it. So that's specifying the author. I'm going to be Margaret Hamilton today. We'll say begin document and end document. And this will be the actual body of our document itself. Everything above this is kind of configuration information and sort of meta information about the document. So begin document, end document. And if I want to have a title in my document, I'll say make title. And what make title will do is it'll take this information here and it'll use it to produce a title automatically. And I could also have some text in here. So I could just say like a demonstration of how to use LaTeX. Okay, so now I did actually leave an error in this. So there is an error in the document and it's this number sign here. And the reason why I did that is just so that way you can see what happens. So remember, LaTeX documents are compiled. So if I try to run this and I get an error, then like a lot of computer programming languages, you get an error popping up and it'll say like, hey, we have a problem here. And you have to fix the errors in the document before it will compile correctly. Luckily, like compilers, it does give you an indication as to what's up. So if I just click on typeset here to try to run this and produce a PDF, it tells me what's wrong down here. So it says a legal parameter number in definition of slash title. And it says here like, you know, line 3 slash title assignment number 1. So it tells me where it is. So if you ever run it and you get an error, just look for the line number, look for what the error is, look for the error message and just sort of work out the error. A lot of times if you can't figure it out, if you just use Google, people will have some solution already kind of figured out for you. So put a slash in front of it. The number sign basically is a special character in LaTeX. So if I want to tell it to actually output number sign, I got to put a slash in front of it. That's all. It's called like, this basically escapes it, we say, and it lets me display the number sign character. So I run this now and I get here the document produced for me. And I get the title, I get the author, the date, and I get this text here. So notice that in contrast to what's called a what you see is what you get editor, say like something like Microsoft Word or Google Docs, I didn't tell it like center the title. I didn't tell it like what font sizes to use for the title. I didn't even tell the date. LaTeX is doing a lot of this stuff for us. And the idea is that's a good thing for us because now we can focus on content and document structure, and we're not focusing on layout. We're letting LaTeX handle that for us. So that's a big philosophical distinction between LaTeX and sort of the what you see is what you get editors. So there's all kinds of LaTeX commands. Like one is text BF. So if I say text BF, open squiggly bracket, close squiggly bracket, that'll bold the text inside of that argument there. So I'll say /env and I'll say how to use. The other thing is a special LaTeX command. So if I say /LaTeX, it'll output LaTeX in a stylized kind of way here. So I get a demonstration of how to use LaTeX, and that's bolded, italicized, and then this has then been kind of stylized in terms of its output. So with LaTeX documents, we can have sections, we can have subsections, we can have subsections. And depending on the document class you're using, so there's different document classes. There's like reports and books and different things you can produce with LaTeX. We're making an article here, so it's going to be kind of a simple article here. But there's also things like chapters as well. So there's different ways of sectioning LaTeX documents, but we're just going to use regular sections. So I'll say here, section 1.1. Then I'll say here, section section 1.2. And if I run this, I get these two sections here. Now notice this numbering here, 1, 2. So LaTeX does its own numbering of sections. And it's another thing that handles automatically for us. I can also have subsections. So I can say subsection, and I could say here exercise 2. And then I could have subsection, and I could say exercise 3. And then I get these subsections here with exercise 2 and exercise 3, and we get the 1.1 and 1.2. LaTeX will even generate a nice table of contents for you if you want to. So it's numbering them automatically, but because I'm doing an assignment here where I've got certain exercises that I'm doing underneath certain sections, and because I'm not making a long document here, I'd rather just sort of number the sections myself like I am here with 1.1 and 1.2 and 2 and 3 here. So if I want to turn off this automatic numbering, I can. I just put a star before the squiggly bracket here. So if you put a star there, what it'll do is it'll turn off LaTeX automatic numbering of the section there. So I run that and it takes it away. So now if I want to start putting actual answers in, I can do that as well. So let's just say underneath section 1.1 here for exercise 2, let's just say it's A, B, C, and I got to answer it like that. I could do it like this. So I could say like A, and I could say the answer is blah, blah, blah. And I could say B, the answer is yada, yada, yada. And I can run that and the text will appear. But notice that it's on the same line. So LaTeX is taking this document and compiling it, and it's looking at the text here and the way it's formatted in terms of new lines to actually determine whether this is a new line or not, or a new paragraph or not. And because there's no space here, like there's no new line character here in between these two lines, it'll actually put them on the same line. So that now that I put this space here, this new line here, what it's going to do is it's going to think that this is a new paragraph. It's going to treat it like a new paragraph. So if I run this now, it puts that on a new line because it thinks it's a new paragraph. It thinks this is one paragraph and this is another paragraph here. Another thing I could do is I could put a double slash here. And when you put a double slash, what that means is after this content here, put a new line after it. So if I do that, what it'll do is it'll put then a space in between those lines. Now, because I'm not writing a lengthy document with paragraphs, because I just want to sort of have a series of answers here underneath each exercise, what I could do is I could modify the default behavior of LaTeX in terms of how it handles paragraphs. And there's all kinds of things you can do with LaTeX to customize behavior. So even though it's not a what you see is what you get editor, you can, what you see is what you get style document creator. You can still edit things if you want to. So I'm going to say here pair indent, and I'll say 0 point. So this is a command that I'm going to put in, and what it's going to say is have my paragraphs have an indent of 0 points. So when I run this now, what it does is it takes away the indent of the paragraphs. And now these two lines are going to be aligned. So that's just something I'm doing just to sort of customize the way my document's going to appear. And I've got those two lines of text there. So LaTeX has all kinds of tools to let us structure our documents. It's got lists, so we can have itemized lists. So maybe I'll just put some new lines here just so we can kind of see more centrally here. So I'll say begin, itemize, end, itemize, and then I can have an itemized list here. And this will be an unordered list. So I'll say item and I'll say blah, blah, blah. I'll say item and I'll say yada, yada, yada. I'll say item and I'll say bleep, bloop, blop. And if I run this here, I will get this unordered list here. So that's, one type of list in LaTeX. You can do the ordered lists as well, where you'd have like a 1, 2, 3 type ordering. So I could do that too. I'll actually copy this just to kind of save some typing time here. So I'll say for my next exercise, instead of begin itemize, I'm going to say begin enumerate. So I'll say enumerate / end enumerate. And now if I run typeset, I get a numbered list here. So while it's not typical, it actually is possible to customize the way the numbering works. So this isn't something that I do like frequently at all. So it's the kind of thing where I had to, Google and figure out how to do this, which is fine when you're doing something like this. So I'll say this /new command, or /renew command, and then say /label enumi, and then I say here /elf enumi. And when I do this, what it does is it changes the ordering style here from 1, 2, 3 to ABC. And I didn't know how to do this off the top of my head, of course. Like things like this you memorize, like how to use an itemized list. Things like subsection and subsection and section and end document, those are things you memorize. But some one-off thing like this, nobody really memorizes how to do those kinds of things. That's the kind of thing where you just sort of, find a good source online that'll show you how to do what you want to do. So, I just researched and figured out that, okay, if I use this sort of thing, I can get this sort of behavior and so forth. So using reference guides is part and parcel to using LaTeX for things that are rare and just things that you just haven't done in a while. So anyways, you can have ordered lists like that as well. So one big thing with LaTeX is what's called math mode. So LaTeX, like I said, is used in a lot of scientific and mathematical documents. And one of the reasons it's so popular for that is the way that it lets you make very neat math expressions that are expressed in a very clear way. So let's actually make some math expressions here. So I'm going to say here /subsection star, and I'll say exercise 5 here. So to go into math mode, there's actually a couple ways of doing it. There's an inline way of doing it where the math expression, the mathematical, whatever it is you're creating, will actually be displayed inline. So not on a new line, not formatted in a particular way. And that's with a $sign. So you say $sign and then $sign. And anything you put in here is going to be done in math mode. And in math mode, you can do things like, x plus y, and you'll get x plus y here, and you can kind of see that it's slightly stylized there. So you can do that. And I'll actually zoom in here just that way we can see these things a bit better. Let me just move up here. So yeah, just zoom in just that way it's larger on the screen there for you. So, okay, that's some basic math there. But what we can do with LaTeX that's pretty cool is we can put in these LaTeX commands that'll give us pretty much any mathematical symbol we like. So let's just say I want to do some kind of propositional logic and have things like disjunction and conjunction symbols and things like this. That's fairly easy with LaTeX, and that's one of the reasons why people like it so much. So if I say here P/right arrow Q/LOR R, and I run this, I get this nicely formatted compound proposition. And I can do that with all kinds of symbols. So if I do // I'll do a B here. I can say $sign, and then I'll say /neg P/left right arrow, and then I'll say Q/O times R $sign //, and then I run this, I get this one. And with all of these LaTeX commands here, you get to know the ones you use pretty frequently. So if you're making a bunch of LaTeX documents with propositional logic in them, you get to know these basic ones that we use all the time. But for symbols that you don't use as much, or if you just forget, again, it's the kind of thing where people just use reference sheets. So if you just go to like LaTeX logic symbols, even the Wikipedia article that comes up has a pretty good list of all the LaTeX symbols that go, or the LaTeX commands that go along with all the logic symbols over here. And there's all kinds of lists like this out there. So here's a bigger list with like all kinds of symbols in LaTeX. And I'll post some links so that way you've got some good references that you can use. So there's all kinds of stuff we can do this. So I'll say C, we haven't covered this yet in class, but I'll say / for all x. And I'll say x to the power of 2 is greater than x. And this is basically just saying for all x, x squared is going to be greater than x. And if I run typeset here, I get this for all x. x squared is greater than x. So this x squared here, that's the important part here. So this hat symbol here, the caret symbol, I believe it's called. If I do this and then I put squiggly bracket and close squiggly bracket, anything I put in here will be the superscript of this item here. So that's why I get this x squared there. And we can do exists as well. So there's exists. We're going to talk about that soon. So I'll say exists x to the power of 2 is greater than x. And then we'll get the exist symbol there. And all this so far has been inline math mode, where it puts the math on the same line as the current text, whatever it is. There is a display mode math, and there's a couple ways of doing that. So display mode math mode will put the text on a new line and center it. So if I say here E and I say slash open square bracket slash close square bracket, and then I say whatever I want to do here in terms of the expression. Let's just say I put y is equal to b underscore 1 plus b underscore 2. This will still format it in math mode, but it puts it on a new line and it centers it. I've got it pretty zoomed in right now, but it's centered. So you can see y is equal to b1 plus b2. So this here, this underscore character here, and the open squiggly bracket and close squiggly bracket, this will make this the subscript of whatever item is here. And so again, it's this underscore character here that will make it the subscript of this item here. There's another way to do the display mode math, and that's just if you just say slash begin, and then you put in here the, what is it again? It's the slash begin equation, and then slash end equation. And then I can put whatever I want in here. So I could just say, you know, x is equal to a to the power 2. Sure. If I run this here, we get the same kind of thing in terms of the display mode. Okay, so next up, let's try to make a table. So if I go down here to this section 1.2, I can make a subsection. Say star, exercise 6. And to make a table with LaTeX, you say slash begin tabular and slash end tabular. And that's the LaTeX command for making a table. And then here you give the columns. You define the number of columns and their alignment. So if I say CC, that'll give me 2 columns. The C actually doesn't stand for column though. It stands for center aligned. So the text would be center aligned. If I were to say LL, it'll be left aligned. RR, it'd be right aligned. And it'd be 2 right aligned columns. So I'll just say CC. And then to define my cells, you basically put your content and separate them by an AND character. So I say, you know, 1 and 2 slash slash 3 and 4 slash slash. And this is basically one cell in the first row in the first column. The AND basically says, okay, that's the end of this cell. Define the next cell. So I define it as 2. Slash slash means next line. Actually, I don't need the slash slash here. And then on this next line here, this is now the next row. And so this is the first column, second row, and then the AND is going to end that cell, and then we're on to the next cell here. So I run this here, and I'll get my table with 2 columns and 2 rows here. If I did try to put in an extra column here by adding in 2 more cells, it's not going to work. I'll get an error. So it actually says extra alignment tab has been changed. So it's basically saying it's not going to work. So we can't do that. We do have to stick to the number of columns we've defined here. It is possible to do things like row span and col span, where you have a cell that takes up more than 1 row's worth of space or more than 1 column's worth of space. But I'll leave that for documentation if you need to do that. I don't think you'll really need to do that in this course. So one thing we might want to do is right now, this doesn't really look like a great table because it's just, there's no borders, there's no any sort of separation of the content here. So if we want to add in things like borders and just putting some lines in between things, we can use the pipe character here. So I say pipe, pipe, pipe. What it'll do is it'll put a border around these columns. And now we get this, right? So now it's just at least a little bit more separated. Then if I want to put the horizontal lines in to separate the rows from each other, I use what's called H-line. So I say slash H-line, slash H-line, slash H-line. And then that'll give me a, oops, sorry, I got to put in some slashes here now. So slash slash there. And yeah, that should be good. Okay. So because I put content underneath this row here, I have to put a slash slash here. And now I can then put the H line here. So if you've got content underneath a row of content like this, you want to put a slash slash afterwards. So run this here, and now I get what looks like a table now. So this is how we could define truth tables. So we could say things like, maybe our first row, we're going to say $P, $Q, and then I could have some compound proposition here, like P conjunction Q. And I've got now 3 columns worth of information here. So I better put another column here, and I'll put another pipe here. So that way it's got a border around it. And then I can put in the truth values here. So I could say like true and true is going to be true. And I can maybe copy and paste to save some typing. So true and false is going to be false. False and true is going to be false, and false and false is going to be false. And now we would have a nice truth table here. So that's what we can use to define things like truth tables and so forth. And it's just a pattern you basically follow. This is, I think should be about as complicated as our tables get anyway. So you can really just use this as a template, because I'm going to post it and just use this to help you out. So one more thing I can show you is how to format proofs in a nice way. So with LaTeX, you can include packages, and the packages basically either extend the functionality of LaTeX with new commands or let you style things differently for different purposes. So I can say here, use package, and then I can include packages. And these packages sometimes get used to format proofs in a nice way. So I'll say AMS Math, AMS THM, AMS SYMB. And these just come with LaTeX when you download it. So you've got them. And when you say use package, it'll just make sure you're using them. So we'll include those. And then we'll just format a proof in a nice way using those packages. So it gives us some more commands that we can use. So I'll say here subsection star, exercise 7, and it gives you command proof. So we'll say begin proof and end proof. And then it also gives you this command align. So we can say slash begin align star and slash end align star. If I try to use this right now, though, it's going to throw an error because I don't have any content in here. So what I'll do is I'll just put comments in front of it now. So you can actually comment in LaTeX. So I could say something like, comment with a % character, and I could say, this is my proof of X. And I can have a comment then in my document. So that way when I'm reading it, I can explain what I'm doing here. Because this would cause it to crash right now because there's nothing in here, I'm just going to say star, or I'll say not star, percentage, percentage, percentage. And what I'll do first is I'll give this sort of preamble to the proof here in this part here. So I'll just say what my proof is going to be about. So I'm going to say here, show that $ negation of P right arrow Q. I got to put the close bracket there, and $ P wedge negation of Q are logically equivalent. And that can be the sort of preamble to my proof. And if I run this now, it should actually say here. So it'll say, okay, yeah, exercise 7, proof show that this and this are logically equivalent. So if I want to use align now, I could uncomment it because I'm ready to use it now. And this doesn't make sense as an explanation, so I'll just take that out. But you can use % to comment things is the point. And so here then I'll put in my proof. So the way it works is actually pretty similar to the tables, where you're going to use and is going to sort of distinguish sections of content that should be aligned with each other. So I'll just show you. So if you say here slash negation of P right arrow Q, let me go put some spaces here just to make it a little clearer. So P right arrow Q, and then I say and equivalent to negation of P or Q and. So if I were to keep going with more lines here and say this and this and this and this, what's going to happen is this and this will be aligned. This and this will be aligned. And this and this will be aligned. So and is going to basically create our points of alignment, essentially sort of like columns. So we'll keep going with this just to show you how it works with an actual example here. So in this proof here, I'm basically showing that this is equivalent to this, and I want to have my justification for it. And my justification is going to be text. It's going to be some, English text that explains why they're equivalent using some rule or whatever it is. So because align puts us into math mode, so everything in here is going to work because align basically puts us into math mode. I actually have to do the opposite of what I do here. So here it's like I use the $ to go into math mode. In align, I am in math mode. Everything in here will be in math mode. So I say slash negation, slash right arrow, and so forth. And these are all going to work in here because we're in math mode. But because I want to put out some text in here, I actually have to do the opposite of what I was doing before. Now I have to say slash text to jump back into text mode. So I say slash text, and then I can put some text in here. So I can say like by the conditional disjunction equivalence, and I put my justification for this logical equivalence in here. And then if I run this here, we get this here. So we get, not P implies Q is logically equivalent to not P or Q. And we say that's by the conditional disjunction equivalence. And that's our justification there. And things are just going to be nice aligned going forward. So if I use these ampersands in the same way, these and symbols in the same way, I can align things in columns, and LaTeX will take care of the alignment for me. So we'll just keep going with this proof here to show you what we mean here. So I say slash here to have a new line, and then I'll say and. I actually am not going to have anything else in this first sort of column of alignment here. So I'm just going to say and. I'm basically leaving it blank. And I'm just going to say equivalent, and then just have each sort of next equivalence and the justification. So I'll say here and then I'll say slash negation of P slash wedge slash negation of Q and then I'll say slash text, and I'll say by the second De Morgan law. Okay, run this there. And I've got my second rule there. Oh, I forgot the equivalence though. I got to say slash equivalence. Otherwise, okay. So there, now it looks nicer. So this is now the next change that I'm making here. And I'm saying this is the next logically equivalent change that I'm making here. And I'm saying, okay, this is logically equivalent to this by the second De Morgan law. So all right, now we can do one more here. So I'll say and this first thing here, this first sort of column of alignment here, it's just blank. That's all. We're just not doing anything there. And then here I'll say slash equivalent to P wedge negation of Q and slash text by the double negation law. And run that. And then we get this. And so this would be a propositional logic proof done with LaTeX. And it's all kind of nicely aligned for us because we're using this align command that we got from those packages. So this is another thing where I will provide this in the example, and I'll provide some links as well to similar things if you want to, just see other examples and see other reference sheets. But this is more or less, what you'll be doing when you do your proof. So you can, again, use this as a template to follow. So one other thing I should mention is, and I said I would mention this, is that the this is the IDE we're using, right? So it's a text editor that's purpose built for LaTeX. I'm clicking typeset, it produces a PDF. And when I do that, it's actually running the command line. So I've never actually used this before myself until this video. I just wanted to show you what it would look like. What I've always just done is just used a regular text editor and then just used a command line tool. So if I just copy this text, I'll just say, copy it all. If I open up a text editor, I use Visual Studio Code. So I'll open up that and I'll just paste it in there. So I use Visual Studio Code. It's a reasonably good text editor. There's a bunch that are good. So I'll save this here to the desktop as demonstration.tech. And Visual Studio Code will automatically syntax highlight for me as well, because, you know, LaTeX is common, so they have support for it. But this is now just, you know, a text document just like before. I'm just editing it in a different editor, right? Because I installed LaTeX on my system, I have these command line tools that I can run. So I can run PDF LaTeX from the command line. So if I go to the terminal here, on Mac, it's the terminal. So if you go up here, you type in terminal, you'll get the terminal. You can also, if you're on Windows, you can go to your search and type CMD. So you go to your desktop and type CMD, it'll bring up your command line there. But from your terminal on your system, I'll just make this bigger so you can see it. But from your terminal on your system, you can then just run PDF LaTeX. So if I go to desktop, there's the demonstration.tech file that I just saved, just as a plain text file. If I just say PDF LaTeX demonstration.tech, what it does is it just compiles it. And if I do an ls now to see the files, it says output written on demonstration.pdf. That's telling me that basically it worked. But if I just do ls, I'll see now that I have a demonstration.pdf file, because it generated that file. It also generates some other stuff too. But if I just say now open demonstration.pdf, it opens up the file for me and it just compiled it just the same as we did in the IDE. So this is just sort of doing it the manual way. And I can see the file. I don't have to use the command line. I could just go to this and just see that the demonstration.pdf file is there too. Open up that way too. So I could use Finder, or you could use Windows Explorer on Windows too, same thing. So if you don't want to use the IDE, that's totally fine. You can use a text editor too, and just use your command line to run things, and that's fine. If you do have an error, like let's just say something's wrong, let's just say I forgot to escape that character, you'll get the error on here too. So if I run PDF LaTeX demonstration.tech and I run that, I will get the error. Just as a side note, actually, just one thing I should mention, because I just ran these commands, if I just hit the up key, if I go up, 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 that actually just scrolls through my recent commands. So I could just, if I just want to run PDF LaTeX again, I don't have to type it in from scratch every time. I could just say up and then just hit enter and run it again. So I'll run it again. This time I get an error and it says on line 4, illegal parameter number and definition of title. So then I put the slash in there, slash number sign there to fix it. Here I could say Q to quit. And then because I just want to compile it again, I just hit up. It's not actually formatting that well, but if I just say up, it's PDF LaTeX demonstration.tech. You can see, run it again. This time it works. Output written on demonstration.pdf, and I can open it up. So if you do want to do it this way, that's totally fine. In terms of good text editors that I would recommend, I use Visual Studio Code a lot. So Visual Studio Code is a good one. If you just Google these, they'll come up. You just download them, install them. Visual Studio Code is a really good one. I've had good experiences with Atom too. Atom's another good text editor, and Sublime Text as well has been another good text editor I've used. But there's all kinds of text editors that are out there that are great, but these are 3 that I would recommend if you want to do it this way. So I'll post this document. It'll have a bunch of comments in it with references to the things that I've talked about if you want to know more about them. But more or less, using this document as a template should actually help you quite a bit with making your assignments in LaTeX. So hopefully this is helpful. We may post additional documents like this as we go to give you more help if more things come up that we want to represent using LaTeX. So this may not be the only sort of template document you get, but this should be a really good start. So hopefully this has been a helpful introduction to LaTeX, and thank you for watching.